Now we'll get on to the definition of R&D. We're going to talk about R&D itself, the international definition by the OECD, the Organization of Economic Cooperation and Development. And then what we'll do is we'll talk about both the Canadian and a bit about the IRS, the United States definitions, to talk about how they're similar and how they're different. Okay? So getting into the international definition from the Frascati manual. And this is a manual that was really developed in the 1960s in Frascati, Italy, which is where I got the name. And it was developed by the OECD, the Organization of Economic Cooperation and Development, in order to determine how regions were developing and why they were developing and how you could encourage that on an international basis. So they came up with an international definition that has actually become the de facto definition in pretty much all other countries. So if we look at the Canadian Income Tax Act, the IRS code, Inland Revenues Code in Britain, they all use pretty much this verbatim definition. And then they might tweak it a little bit. So they say for a project to be classified as R&D, its completion must be dependent on a scientific or technological advance. And that will be the magical word for today. The Canadian Income Tax Act talks about technological advancement. And then all of the other concepts really come from the Canada Revenue Agency. So we'll talk about what the Income Tax Act says as a technological advance. And the aim of the project must be systematic resolution of a scientific or technological uncertainty. So again, we've taken these terms and we've put them into the Canadian tax system. So going to the Canadian Income Tax Act itself, it said that SR&ED is a systematic investigation or search. So we're taking, again, the international definition. It's carried out in a field of science or technology. This is very important. So we'll talk about what are eligible fields of science and technology and what are ineligible fields of science and technology. And again, we rely on an OECD definition. So there's an international definition, and this seems to be in place in every country that uses these types of credits. It's done by means of experiment or analysis. Okay? So they don't tell you how to do your research. They just say it has to involve experiment or analysis. They talk about basic research where you don't have a specific application, applied where you do, or the vast majority of work is called technological development. And quote, technological development is any work that's aimed at a technological advancement for the purpose of creating new or improving existing materials, devices, products, or processes, including incremental improvements thereto. That's the way the Act reads. So they're saying you could be developing a brand new product or process, or you could be improving an existing product or process in some measurable way, as long as it involves technological advancement. So again, the Act really focuses on that term. What is technological advancement? Now, very importantly, the Act then goes on to specify that there's 8 types of supporting work, that as long as they're necessary, they're included in the R&D claim process, or the definition of R&D. The first 4 are the types that I find people would assert or automatically, without any predisposition or pre-proposal of what R&D is. If I asked a researcher, what do you think R&D is? What activities would be included? The engineer designing things, testing out the results, doing analysis to figure out which formulas are the best. Most of us would think that's the R&D, the actual doing the research, the thinking, the planning, the design. Those are the obvious ones. As we go down the list, it tends to become more of a gray area. So there's the black and white, the things that almost everyone would agree are R&D, and then there's things that people may disagree whether all or part of this is the R&D. And this is really where the judgment applies in the R&D process. So the Act says that any computer programming that's necessary to resolve the project objectives or answer the uncertainties, thus achieve the technological advancement, would be in. I may in fact have a machine that I'm developing, a new robot, and I have some uncertainties on how to design the robot, and I need to write computer controls or PLC controls to control it. At which point, all of the costs to do the computer controls or make those work so that I could test it would automatically be in, even if there's no uncertainty on how to do the computer controls or write that code itself. Okay? So these kind of go hand in hand. Any computer programming that I have to do, any data gathering and testing that's necessary to resolve the stated uncertainties is in. So judgment becomes applicable on how large a sample size do I use, how how much is appropriate, and whether something is testing. All right? So again, there's generally the obvious R&D things that you think when you have a project that you think is research, and then there's additional activities that continue on. So the questions become, when does the R&D project start, and when does the R&D project finish, or SR&ED project in Canada? Lastly, I'm going to talk about psychological research, which is listed in the Income Tax Act as a supporting activity, but should be qualified. The real issue on psychological research is that we'll see in a couple more slides that psychological research is actually classified as a social science. And one of the things that's not in is social sciences. So we'll say, well, how can you put psychological research in when it's a social science, and then the Act actually pulls the social sciences back out in another section? So psychological research is one of those quasi areas of science that, according to the CRA, they'll allow it as a supporting activity for certain things, primarily drug studies, where you've done the chemical studies, you've done the biological studies, you're on human testing, and they believe that the psychological studies are directly tied to the biochemistry and therefore a supporting activity. If you try to claim psychological research in things like are computer programs more intuitive or things like that, that will generally be seen as a social science and disallowed. So again, there's a little bit of ambiguity there that you kind of need experience to understand. Where does it apply and where does it not apply? And this is not really explained very well, I find, in CRA documents. The Act then currently goes on to list a whole bunch of activities that are not R&D. And there's a big argument for a number of years to take this section out of the Act because it's not really law. They're saying what these are really examples of things that if you understand the first part would be things that are obviously not part of the SR&ED. So they're more illustrations or examples. The commercial production of a product occurs on almost every R&D product that gets successful and goes into commercial production. So there'll be an R&D stage where you have uncertainties that you're trying to figure out. You may be doing testing. You may even be selling some of those prototype products at the end of the day. But the point is, you've still needed to produce more products to test them and understand the optimal way to design and make those work, to resolve your uncertainties. And then there's a point where you say, I think we've got everything figured out. We do our Six Sigma models and whatever, and we say this is how we're going to manufacture it. And we don't really change anything from that point on. That would be the commercial production. Again, there's arguments of how much of that would I need to determine if I have faults or tolerances or whatever, but generally there's a reasonableness point on where's the cutoff between experimental production and commercial production. And that point is where it appears you've resolved your stated technological uncertainties. So how you state your uncertainty will predicate where the commercial versus experimental production phase transfers. Other things like quality control or routine testing would be taking every 1,000th widget off the line just to make sure your line's calibrated properly. Again, these kinds of things are not in themselves SR&ED. If I make changes to a process and then I have to test how it works to see if my hypothesis is correct, that would not be quality control or routine testing. That would be experimental testing. Okay? We'll talk about social sciences and humanities, and then we'll illustrate something, an aesthetic or a style change. And this is very important. An aesthetic or a style change is a change in something that's not measurable. So if I say I like this wall to be greener or lighter or prettier, something that involves value judgments or objectivity are generally not seen to be scientific. So if I was a paint or resin developer and I wanted to talk about a color of this wall that I'm trying to develop, and I said it was nice or greener, that would not qualify. That would be, in the government's terms, how a layman would talk, right? Scientists may, on the other hand, talk about how I want the chromography to be on a certain scale at various different angles and what those numbers would be or represent, gloss, things like that, and how to achieve those with wear life or paint life or all the other things that would become involved. So again, when I get to the science of how do I make that end product work, that would be the kinds of things that we'd see as eligible. Yes?
For market research, say you're evaluating competitive products and comparing that with an experimental product.
Okay. The question is, I'll just repeat it the question is, what if on market research, and this is a great question, and this is really kind of one of the fundamental questions that got me to recommend the process that I recommend to people to document SR&ED now. On market research, what if I'm looking at competitive products? Okay. Is that data gathering that's relevant to my hypothesis, or is that market research? So how many people think it's market research? How many people think it's R&D? How many people think it might be both? Well, the answer is it depends. Okay? And this is what I believe the law says. The law says, and this is a classic example, and this is how it usually works. I have an idea or a concept, and maybe I go and do a competitive search or a patent search or whatever, and I look at what other people have done. And maybe I look at 30 competitive products, or 40, or 50, or 100, or 1,000, who knows. I look at some, and after a point, I start to say, hey, you know what, my idea might work, and there's stuff that's similar, but nothing exactly similar. Okay? So I start to phrase the hypothesis. To me, the hypothesis, and we'll talk about what's the definition of a hypothesis later on, because really that's what the courts get into. Well, hypothesis says you have existing models, you've looked at what competitors have done, you have what they call a due diligence or standard practice, so they use very different terms. Prior art is the term they use in the patent community. You've done a reasonable search based on the business context of the firm. Okay, so I'm getting onto a little slide ahead, but it's relevant to this slide too. And we'll just skip it then. So what that means is that a company, who's a 4-person software development company in Hamilton may not have the same resources as Microsoft Canada. They may not be expected to do the same level of due diligence. They'll also look at the size of your project. You would assume a $10 million project would have more due diligence than a $10,000 project. But again, I don't know. The $10 million project could be so advanced that nobody really knows about it. There's very little due diligence to do. It'll always be based on the facts. What I believe the courts have said is any data gathering from the point you phrased the hypothesis is in. Okay? So if you had no hypothesis while you did all 80 patent searches, then that's all pre-SR&ED. If by the time you hit the 5th patent, you said, you know what, I have a hypothesis that a combination of temperature and pressure and whatever, some combination of variables could be the solution I'm looking for, right? And now I'm going to start to narrow my search to see, what have people done on those things. I would argue that from the moment you can illustrate the hypothesis, and this is what the C will ask you, when did you first phrase the question? When did you first recognize a problem formally and write it down? So they have questions that kind of elicit that from you. Everything from that point on that's aimed at resolving that problem is in. Okay? So my answer to this is always, it really depends on when you've defined the problem. As soon as you've defined what the government would call technological uncertainty, you're in. Okay? All right. And last, so we talked about style changes. So providing measurable objectives is critical. The measurable objectives usually stack up. I want to hit something with this strength and this pressure and this cost. And now that I put all these components together, I can't use the same components as I otherwise would. So this may create the technological uncertainties, force me to use new products, new techniques, new materials, new procedures. And lastly, there's an 18-month deadline for corporations from their fiscal year end, which is an absolute deadline. Generally speaking, your tax returns have to be filed 6 months from your corporate year end. The Act gives you another year. The Canada Revenue Agency really doesn't like that extra year being provided, so they tend to be very, very strict about that deadline. I would recommend that if possible, you always file at the 15-month deadline from year end, in which case the Canada Revenue Agency says if you've missed anything, we'll give you another chance. If you file at the 18-month deadline and any piece of information is missing, any schedule, anything, you'll probably lose the entire claim. Okay, so the IRS code in the US talks about a 4-part test. They talk about a project being technological in nature. It has a permitted purpose of discovering information, elimination of uncertainty, and a process of experimentation. So what I'm saying is the concepts when we go from country to country are almost identical. The terms they use are slightly different, but the base concepts of what I would call the square, triangle, and circle are the same. Okay. So we talked about eligible fields of research and ineligible fields of research. The eligible fields of research are your natural sciences, engineering, medical, health science, and agricultural sciences. And these are from the OECD. Now, as we mentioned, the social sciences and humanities are excluded. They would include things like psychology, accounting, economics, studies. These are all things that are rife with uncertainty, but you won't get any credits for them because they're not fields of science or technology. Now we'll talk a bit about, now that we've talked about the Income Tax Act definition, we'll talk a little bit about the CRA's definition. So what happens here in Canada, and this is an important point, and it happens in all countries with tax credits, is that the elected officials, the people that we vote for in our parliament, pass this legislation to have it applied to taxpayers. And our elected officials write legislation, and when they pass it, they write things called technical notes. They debate it in the House of Commons, in the Senate. They get something called royal assent, and then it becomes law. And you can go back, you can read the technical notes, which is not only the legislation itself, but the technical notes are kind of the layman's terms of what do we tell the politicians in Parliament that are voting for this, what is the purpose of this? Because they don't all, not every politician is a lawyer or familiar with reading legal text. We want the plain language explanation of why should they vote for this and what is it doing. So I rely as much on the technical notes as I do on the legislation itself. What was the object and spirit of the legislation that our elected officials thought they were voting for? And then they pass it. Then what happens is it gets handed over to the Canada Revenue Agency, who then enforces that legislation. Now it's important to note that the Canada Revenue Agency is very much like a police officer that enforces the legislation that our elected officials passed. It has no ability to create its own laws or legislation. And really, its interpretations ultimately should be in line with what our elected officials passed. It shouldn't be creating its own variations of this. So what happened was there was a series of papers that were developed with industry over about 20 to 30 years, from about 85 onwards. And in 2012, those were all erased and replaced with a different, more concise set of papers. Okay? According to the CRA, there is no change in policy. That all of the policies that applied before are still in place now. So we'll talk about that as we go on, that I've noticed certain things were missing. They were in the older papers, but they just didn't appear here anymore. So has the policy changed or not? And we'll talk about whether that applies. According to the CRA, formally no, but after 3 or 4 years now, I can show instances where, yeah, the policy in fact has changed because of something being omitted. So these are a concern, especially when you have a government right now that changes policies and then you see a sharp drop off on the number of claimants and a sharp increase in the number of objections. Okay? So they also publish manuals for the steps a reviewer should take. There's both a technology reviewer, what they call RTA, Research and Technology Advisor, and a financial reviewer. So you'll see responses from both types of reviewers on different claims. You may have one review it, you may have both review it, or neither. You may have a desk audit. So going on to the Canada Revenue Agency's definition of how do they want you to report SR&ED. So we talked about the OECD, we talked about IRS, the Government of Canada's tax code, and the Income Tax Act. We're saying, well, that's great. I have basic research, applied research, or experimental development, but that doesn't tell me what do I write down to the government to prove that I've done these things. And what the Canada Revenue Agency then comes in and says, well, what you want to do here is you want to describe the work that you've done at the project level. And they believe that every company follows something called an activity, project, program hierarchy. Okay? So a project is a set of interrelated activities. They're things that you do in order to attempt a technological advancement. This requires you, so that's the term in the Act. So this is the only term that we're going to get in the Act. They're saying that to achieve technological advancement, much like the IRS, this requires overcoming technological uncertainty and is pursued through systematic investigation by qualified individuals. Okay, so they've added the term, you got to be qualified. Now, what does that mean? Well, generally speaking, if you have a Bachelor of Science or equivalent in the field of technology, you'll be deemed to be qualified. If you have a college diploma there, you're usually deemed to be qualified. But you don't necessarily need formal training. There are some people that may have, particularly software, be trained in a completely different field, but have 10 or 15 years experience and have learned those skills. So at the end of the day, whether you're qualified or not could depend on formal training, but very often it could depend on actual knowledge. And we'll talk about how to illustrate whether you're qualified or not using factual or scientific evidence. Okay? So I mentioned earlier that the CRA feels that all SR&D or R&D programs follow something called an activity, project, program hierarchy. about the activities and how they fit into projects, but we haven't talked about program. What's the difference between an R&D or SR&ED project and an SR&ED program? And the main difference here is that programs are ongoing. And projects, generally speaking, have an estimated completion date, according to CRA, of 3 years or less. Okay? So I may have my cost reduction program. I want to reduce all the costs of everything I do to 0, but I'll probably never do that, in my lifetime. The project could be, I want to take this widget that costs me $100 right now, and I want to figure out a different way to process it so I can get it to $98 by the end of the year. Okay? Or use different suppliers, or some measurable performance improvement that involves experimentation. So, again, projects will generally have timeframes of 2 to 3 years, and programs will be ongoing. If I have a project that I say is ongoing, the CRA will not accept that. They'll say that's a program. All projects need estimated completion dates. Okay? So that's probably the main differentiator. So how do I illustrate, what do I document then in the CRA's definition of a project to show that I'm in the realm of experimental development, as they call it, or that I have an SR&ED project? And the first thing that I like to refer to is called thinking outside the box. So thinking outside the box has different terms. In the patent community, they'll call it advancing prior art. In the SR&ED community in Canada, they call it departures from standard practice. But again, they all have fundamentally the same definition. I've talked about the objectives of my project, what it is that I hope that I'm doing. And then I've talked about what is known. What do people already know about this? Are there competitive products? Are there patents on this? Are there different ideas? Are there concepts that aren't necessarily competitive, but I could take ideas from this industry and move it over to my industry, or the concepts, or anything like that? So the first question is, how do I benchmark standard practice? And what I'd say is you get some type of grid. What are all the possible things that you can do to benchmark standard practice? Well, I can do internet searches and find articles. If I go to Google Patents or one of the patent searches, we can do those. If I look at competitive methods, that's often a great one. So what are my competitors doing? I could look at things that I've done myself. If I have some proprietary technology that I'm building on, that's often a great indicator because I built it. I can't go ask the vendor. I am the vendor. So I don't have anyone really to direct me there. Again, it's a form of, or illustration that I'm taking objectives beyond standard practice. Okay? Component suppliers can often be a great source. I'm mixing this new chemical batch, and one or more of my chemical suppliers may have invented something or have an idea that can help me. And then really the last couple are kind of catch-all. Queries to experts. Query to experts could be free advice on a blog, or $1 million study that I pay someone, or kind of anything in between. It's whatever I did here to say, how did I take advantage of readily available information to show that I'm a qualified personnel, or my team is. So what I'd like to do is say, okay, let's take all this information and let's talk about all my benchmarks. What's my current cost? What's my goal? What's my current performance? I want to go to, I'm at 800 PSI pressure max and I want to go to 1,000 or whatever. And I start adding up all these things. I'm on 5-axis and I want to go to 6-axis or 7, whatever. So list all the most significant things and give me an appreciation as the reviewer. So let's say I'm a CRA reviewer. At the end of the day, would trying to achieve all these objectives together create a problem? Okay. Any questions on that? Okay, so the first thing is, after we've done this due diligence and we've looked at our objectives, are we thinking outside the box? So the next question would be, how do I illustrate my hypothesis? The government says I need a hypothesis or technological uncertainty. And generally speaking, what we'll have is we'll have a series of variables. The variables, you could call them W, X, Y, Z, A, B, C, D, whatever the case may be, but a variable will be something where I make a change in one variable and it could have an unpredictable upstream or downstream effect on other decisions. In Canada, they call that system uncertainty. So if I have, I'm making a mold and I have temperature as one of my variables, if that's my only variable and I'm playing with temperature, how long do I quench it or whatever, they'll probably say that's fine tuning. It's only one variable. If you have a skilled person and we're willing to sit there long enough, you'll get the right answer. It's singular. It's like tuning a radio. It's just a matter of time till you get it. There's no technological uncertainty if there's only one variable. If I say, well, the optimal temperature depends on the pressure. If I change the pressure, the temperature, and vice versa. Okay? So now I got system uncertainty. This is important. So if I have 10 tests for temperature and 10 tests for pressure, first people might think I have 20 tests, right? But in reality, I have 100 tests in my matrix because, for each of the first 10, I got to do 10. What if I add another variable, like the amount of glass fiber in the mix? That could affect rheology and other things, which could affect temperature and pressure. So now, technically, I have 1,000 tests in my matrix. And every variable that I add on, it becomes geometrically more problematic. So my magic rule of thumb is to identify at least 3 variables of system uncertainty, where a change in that variable will affect or could potentially affect one of the other variables. It's not independent. We're changing that, doesn't affect anything else. Ideally, I like to identify up to the top 5. If you can get 5 or more and show that there's no existing solution that tells you the optimal combination, there's no existing SolidWorks flow models, there's no existing models that give you the starting point that are more or less your answer. And this happens all the time because there generally are models for things that exist. But there's new products and materials coming on board all the time that aren't modeled because they just never really existed before, and now you're trying to use them. So you have to be specific about what are the things I know, but what are the things specifically I don't know that I think I'm going to have to figure out or understand the relationship of to achieve my objectives. Okay? This is probably the most important part of the whole process. This is the part where if the managers do this correctly, the rest of the SR&ED project falls into place. We say, Joe, you do this, and Susie, you do this, and Bob, you do this, and we'll meet next week or next month or wherever, and we'll go over what we're doing from there. And what I found is the very successful SR&ED teams do this in their first meeting when they have the new product. Hey, Eureka, look what we thought of. It's like the KX7 project from last year, but different in some ways. Here's how it's the same. Here's how it's different. Here's the variables that we really think we're going to have to experiment with, and get the team to brainstorm that, agree on that, and communicate that. And then they can go off and do their own thing, because whenever anyone does anything that he or she, in their professional opinion, feels, hey, this helped me or the team in some way understand the interrelation of these variables better, that's a technological advancement. And the failures are often evidence of technological advancements as much as the successes, the product successes. So every time you have a failure, you want to ask yourself, why would we not do this again? What do we know now that we didn't know at the start as to why this didn't work, or why this combination didn't perform as expected? So it's the conclusion, using the scientific method, what we normally call the conclusion, not the results, but the conclusion right at the end of the project. Not the what happened, the why did that happen, that is evidence of the technological advancement. Okay? Communicating the variables, agreeing on the variables of uncertainty, communicating them to the team, and allowing the team to document anything they do to learn more about those variables is what I find the successful documentation processes tend to do. Okay? So once we communicate that information to the team members, what information do we need them to document for us? So the best thing to do in this situation, I've found, is to put myself in the seat of the CRA, Canada Revenue Agency reviewer, the desk reviewer, the person who's sitting at their desk and wants to give you this money. They want to read the descriptions. So roughly a third of the claims go through pure desk review. They don't have any more detailed review than that. Someone reads the descriptions and says, yes, this looks like it qualifies. The costs appear reasonable for the work done. We can just assess this client as filed, and we don't need to do anything further. Okay? File's closed. So that's the goal that most claimants want to get to each year, is the pure desk review. And what I found is there's a couple facts that will encourage that to happen. One of the first things is can the reviewer not only understand the technological problems or uncertainties that you've gone beyond standard practice, which is of course paramount, but also do the costs appear reasonable? So when they read it, they say, well, this is good science, but I don't know if this is 30 man-hours or 300 man-hours or 3,000 man-hours from what you've written. It's very hard because you said, we did several experiments. We did various of these. And generally speaking, scientists don't talk in vague terms, as we said. They say, we did 17 experiments. Here's how we did it. I use an example of a client that I had that had a project of over $1 million. This is going back decades now. And it was written on less than the space that you have for a project. So it was very concise. And it talked about, we did 43 different prototypes, in 7 different classes. And here's what was different about each class. And within the prototype classes, here's the variables that we were experimenting with. And the reviewer came in and he said, well, I used to do this kind of work in industry. I understand you're doing concrete and thermal rise and different things in here. And there would be all those problems. And he took a look at how long he thought each prototype would be, probably 500 to 600 man-hours times 43, which is easily the $1 million that the client assess as filed. Okay? So the important point is that the reviewer had information like 43 prototypes, and he knew roughly what was involved in a prototype and what a reasonable amount of time would be, whether it be 500 or 600 hours. And they're usually not going to come back and say, you said 100 hours and I could have done it in 90, like your boss might. The CRA reviewer is a gross reasonableness. You say 100 hours and I don't see more than 5 from what you've written. Now I'm going to have to ask you, show me all your information, show me all your notes, show me how did you spend 100 hours? Because maybe you just think, some people just think a lot, before they put pen. I don't know, but the more questionable that appears to be, the more likely they're going to come and ask for information or proof that you really spent the time and effort that you did. So the more complete you can provide the information to them. So I'll not only try to talk about how many of a different thing did I do, but to appreciate that certain things take less time. So when I look at alternatives or simulations, I can often simulate things on a computer. I can do 1,000 alternatives in seconds or maybe hours. Okay? But then typically what happens is I take some of those ideas from my models and I go on the shop floor and I run it through the processing line. Well, now we got 30 or 40 people involved. We've got to clean machinery, flush it, put it back, recalibrate it, do all those things. That takes significantly more time. And then so that may be tens or even hundreds of hours as opposed to hours. Or we say, we can't tweak the existing line, but we have an idea for a whole new paradigm. We'll redesign this whole line from scratch. Well, now we could be talking thousands or tens of thousands of man-hours. So again, when you write these descriptions, keep in mind that the person reviewing it doesn't really know anything about you, your company. I mean, they might do a website search and see what you've got publicly available, but they don't really know about that product. So I'm saying always, when you're describing this or reviewing the descriptions for submission, ask yourself, as someone skilled in the art, would I feel comfortable that not only the research is aimed at technological advancement, but secondly, that the costs that they've described appear reasonable. And then try to put information in the description of the activities that allow the users to make that, the reader to make that conclusion. Okay? So what I now do in the activities section is I say what we want to do is we want to tie in all the stuff at the start. So the manager generally gets the team to agree, what's the square, what's the triangle? What are our objectives? What's standard practice? What are the variables that we're going to have to experiment with that aren't adequately defined in standard practice? So for each of the objectives, we want to get a result. So did I achieve my cost constraints or did I not? Did I achieve my pressure constraints? All the performance criteria. If we're bang on in each of them, well, that's good. We probably knew what we were doing. I tend to focus on the ones that we're not. We're at 0% of objective, or at 300% of what we expected. So the further we vary from that, how could we at 3 times what we expected to happen, our objective? Probably something unexpected happened there. And that's what we want to focus in on explain. So the results are merely indicators of things that maybe this needs a little more explanation. But the results don't really get us the credits. We don't have technological advancement unless we can explain why we got those results. And that's the difference between what they call trial and error investigation, which is never allowed, or systematic investigation, which is what's required under the Act. So the trial and error person gets to hear, oh, result number 7 is the best, the client's happy, we're off. Okay? And what they'll say is, if you don't know why result number 7 was better than any other results, if you can't conclude why that one was better, the next time you have this problem, you're going to have to do random investigation again, because you didn't learn anything. Okay? You didn't have technological advancement. So it's the conclusion at the end of the day on those variables that represents the technological advancement. And that's all that's required to claim the credit. Okay? We don't have to be successful. A failed product can still represent technological advancement. And on the flip side, a successful product does not automatically indicate technological advancement. So those are different concepts. One's a scientific one, and one's more of a business concept. All right, so putting this all together, really what we want is we want the manager or the team as a whole to get together at the start of each new project. And then that first 15 to 30 minutes in the Eureka stage, talk about what is it that we know and what is it that we don't know. So do your patent searches, do your prior art searches, do your competitive, analyze those things, and try to flush that information out. If that happens, then we find that the investigative activities that they talk about can be done by different individuals in different countries, often in different languages. But as long as there's that common understanding of what are the uncertainties or variables that we're working with, we can all share our conclusions and advance that knowledge cooperatively. So this is merely a sample template of what we would suggest. The Canada Revenue Agency has its own form in the tax form, and that's all you really need to fill out at the end of the day. So what we want to do is talk about step 1.1. What's the state of existing technology and how does that compare to our objectives? Okay, so list top 3 to 5 objectives and try to benchmark as many sources as you can, whether it's patent searches, competitive products, whatever, how they work. Then try to formulate the top 3 to 5 variables of experimentation. Hey, some crack teams can do 10, 20, 50 variables. The more variables, the better. After 5, you're pretty much in. I would say if you're going to go more than 5, the real trick here is to rank those variables in what you perceive to be their order of significance using your professional judgment and focus on the top 5, because that'll make the project simpler and easier to follow. Okay? Then lastly, show that we're learning about the interrelation of those variables with our experiments, talking about not only how many we did, but what method, to give the reader an appreciation for that the time that we're claiming is reasonable. And to give ourselves an appreciation that the time we're claiming is reasonable. To look at it and say, yes, I believe that time is reasonable, and it was all necessary to resolve the stated uncertainties or to learn about those variables. Okay? So the results should correlate to objectives, but most importantly, the conclusions should correlate to the variables. And it's the conclusion that is the technological advancement. Okay? So until you hit the conclusion, you haven't finished. It's sad when you see clients get to the result stage and they stop the project here and then they run into problems on the review because, again, they've only given the business results, not the scientific results, which is the conclusion. Okay, I'm going to go very quickly through some of the tax court processes. Again, this is more for people who are kind of going to the objections level and looking at where are we going to go with a claim that gets denied or potentially denied by the CRA. So what they talk about is a document here, a guidance document that talks about the role of the tax court versus the expert witness. It talks about the tax court process, defines scientific method, and it looks at what we do here is we look at the tax court versus the CRA requirements. Okay? So the template that we looked at is very simple. Benchmark your knowledge, quantify objectives, correlate experiments, ensure research done systematically, and clarify the technological advancements. So we've talked about the CRA's new policy documents that replace the old documents. What they've said is they have their 3 criteria, but the Tax Court of Canada has 5 criteria. And I guess I myself have taken those 5 criteria and kind of tweaked them into the 5 criteria I talk about. So I've already talked about the CRA definition of a project, set of interrelated activities, attempting technological advancement which requires overcoming technological uncertainty. It's got to be done systematically by qualified individuals. So technological advancement and systematic investigation are the terms used in the Act. The technological advancement is really the overriding one that we want to make sure that we meet. We've already talked about the Income Tax Act definition. The experimental development envisions technological advancement for the purpose of creating new or improving existing materials, devices, products, or processes, including incremental improvements there too. Okay? So it could be developing a new product or process or improving the existing one. And there's no minimum requirements. I don't have to be 10% better than I was before. I could be 1/10% better. The courts have actually said that most technological advancement involves infinitesimally small incremental improvement to existing technologies. So it doesn't have to be a huge paradigm shift, earth-shaking advancement. Most industrial R&D is in fact kind of boring, small incremental improvements year after year to tweak the technology and squeeze out incremental profits at a relatively small scale. Okay. So I won't go into these are just more resources that I've left in there about the tax court process and the role of the expert witness. The role of the expert witness is one that's really important. And often when I talk to CRA reviewers, I don't think they're always in line with what their role is, and it's important to keep that clear. So the courts have said, in more than one instance, that what constitutes scientific and research for the purpose of the Act is either a question of law or mixed law, and is to be determined by the Tax Court of Canada, okay? Not by a Government of Canada expert witness or a Canada Revenue Agency reviewer. Okay? The courts are clear on the idea that our elected officials pass these laws, and that's what they're going to follow. And the CRA are like the watchdogs, the police officers that enforce them. But they don't create their own. They don't vary those laws. They don't take different interpretations of them. They don't make personal interpretations. They don't do a lot of things that certain reviewers may in fact be doing. They're saying that the expert witness is not to tell the judge whether it's SR&ED or not. The judge decides whether it's SR&ED or not by asking expert witnesses certain questions. They're saying that the role of the expert witness is to be a set of prescription glasses through which the technical information can be viewed. And judges are very good at that. They'll take two experts and they'll say, you think this was routine and readily apparent, and you think this was technological advancement. Why do you think it was readily apparent? And he'll say, well, here's 5 theorems or 4 published articles or whatever that support that this was readily available. And then he'll say, well, why do you think those did not solve your solution or provide this? And they'll say, well, these were missing one or more variables. And then they'll listen to the 2 experts argue. And judges are pretty good at pairing them off and then deciding which appears to be more correct based on the factual evidence. So the judge will say, both sides bring all the evidence you can, and I'll decide whether you did a reasonable amount. Because it's not for a scientist to decide whether something's reasonable. That's a judgmental question. Again, the judge may apply, well, if you're a smaller 5-person company, you may be expected to do less diligence than a 5,000-person company. Again, that's at the judge's discretion, and the judges are pretty clear that it's going to remain at their discretion because this is an issue of law when we're talking about tax credits. Okay? So very important. So the judge will never really ask the expert witness, do you think this is SR&ED? He or she will ask the expert witness questions to determine him or herself whether they think it's SR&ED. Okay. Again, I won't go through the 5-stage process. I think we've already talked about that, but it's very similar, and we'll illustrate on some tables here, to the grid that we're using. And lastly, when you go to court, this is more of a study I did for myself, that there's a lot of reference to the scientific method. And I love these references because ultimately that's what we're documenting here. And I say I love these references because, particularly in Southern Ontario, I deal with a client base that's multinational. I mean, one day I'll be dealing with someone from Russia, then from China, then from Africa, then South America, and then the United States. And there's a lot of differences in how they do things and the cultures and everything. But one thing I can say is if I say scientific method, everyone knows exactly what objective, hypothesis, analysis, results, conclusions. That every country, every language, every culture, scientific method is easy to understand. And if I say, look, we're documenting a scientific method, everything falls into place. All of a sudden the confusion goes away. At a basis, they may have questions about this area or that area. How do you document the uncertainty? But that's actually the questions that I want to get. the understanding of what we're trying to do and why we're trying to do it is inherent in every culture, I'm saying, if you say scientific method. So the first thing I try to do is say, well, here's what you call scientific method, and that's actually exactly what we're doing here. We just break it into maybe a few more steps or a few less steps than you might be used to. Okay? So again, here's some comparison of scientific method, tax court method, CRA method, and our proposed method and how they line up. If anyone has problems sleeping, this is a really good chart to post on your wall. All right. So what I'll do is I'm just going to highlight, and there's a whole listing of tax court cases at the end of ones I've compiled on different issues that I think are particularly useful when you're dealing with those issues. Some of the ones that I've talked about at just the different stages of the documentation process. And to say, what is it? We've heard what the CRA wants, but the CRA changes its papers often. I'm more in tune to say I'm going to stick with what the Act says it wants and the tax court say they want, because that's pretty stable. The Income Tax Act legislation hasn't changed in a long time, and it's pretty stable. The tax court cases and precedents that come up are permanent. You can't erase a tax court precedence. 100 years from now, I can go look back at precedents. I can look back now at case precedents from 150 years ago on something and cite cases. Okay? So some of the things that cases dealing with different steps. So how do I define knowledge at the outset? In the case of Northwest Hydraulics, they say that the CRA's position was work refers to standard devices and processes which are routinely used in similar situations all around the world. So Northwest Hydraulics Consultants was a landmark case from 1998 where you had some world-leading engineers, PhD, PhD type guys who were professors, and they developed all kinds of hydraulic models for things like dams and rivers and to prevent sedimentation. We're going to talk about one of their projects. But the court actually said it was innovative combination and alignment of the factors that made the project unique. So they're saying, okay, you guys are engineers with lots of experience and world leaders, and yeah, you've built hundreds or maybe thousands of dams before, but these ones were different. Just because you've built one dam doesn't mean you'll know everything there is to know about every dam in every situation in the world. Okay? And ultimately, that's partly why the client won. So the indications here is that often the CRA will think things are routine engineering, and they don't provide any evidence. They don't go benchmark, well, here's where the standard practice was, or here's a report where they would have done it. They just say that, and now you've got to dig yourself out of a hole, which isn't really that fair. You did all the work, and they just come in with a summary conclusion without necessarily the backup. Okay? So again, to protect yourself, what we found is identify the variables and benchmark against standard practice. There's no minimum amount or maximum. It just has to be reasonable. What's reasonable? I'm saying the more you do, the better, generally speaking. In the US, the IRS has a directive called Patent Safe Harbor. Okay? It says if you filed for a US patent on it, you automatically qualify. We don't need to waste resources because that's kind of the idea of what we're looking for. So they've also said that if the IRS reviewer, similar to the CRA reviewer, wants to deny a project, they actually have to do something called a rebuttal presumption, which they have to provide evidence. Here's evidence where your solution was there, and it would have been available. It's not a competitor trade secret. It was readily available to you as someone skilled in the art. So again, when I talk to people in Canada, we say, well, this is all part of the spirit of our legislation. It's just not enacted right now. That we should kind of be following more of the IRS position, and probably we will. Why do we want to quantify the objectives? Okay? So the case of SAS manufacturing, the judge said systematic investigation connotes existence of controlled experiments and highly accurate measurements. Involves testing of one's theories against empirical evidence. Okay? He then goes on to say, without such measurement and analysis, systematic investigation cannot exist. Okay? So again, measurement where you have it, microns, things like that. Courts love microns, that's extremely accurate measurement, right? Provide that all the time. Okay? Don't talk about better, stronger, faster. Quantify everything you can all the time, because the objectives tend to stack up to create the uncertainties, and it also shows the systematic investigation. It's got to be measured, it's got to be recorded. It can't all be done in your head or involve judgments rather than measurements. Okay? They say, again, most scientific research involves gradual, in fact, infinitesimally small progress. All right. the crux slide, hypothesis. How do we define a hypothesis? How do we show technological uncertainty? So in different cases, CW agencies, the judge says the word hypothesis is normally considered to mean a provisional concept, not inconsistent with known facts, serves as a starting point for further investigation by which it can be proved or disproved objectively. So again, what we're saying here is exactly that. The hypothesis is, after looking at what's readily known, what's standard practice, what's prior art, what competitive products and information we have in there, these are the variables that we think need to be adjusted to achieve the objective. As opposed to an infinite number of variables, we think it's these 5 or 7 that are the key variables. And if we can model those and understand them, we could achieve the objective. So again, what's a hypothesis, tentative assumption, things like that. The easiest way is to benchmark standard practice, and then what we found is show understanding of the variables you're going to experiment with in order to achieve it, and rank those. So again, why are variables so important? In the landmark case of Northwest Hydraulics, the judge concluded on eligibility saying that I do not think conventional engineering, i.e. standard practice, would be adequate to deal with the variables and the uncertainties that were inherent in the major disruption and diversion of the flow of a river resulting from the construction. Okay? Technological uncertainty is something that exists in the mind of the specialist, such as the appellant who identifies an articulate and applies it to methods that remove that uncertainty. So again, we got to benchmark standard practice. We have to be specific about what our hypotheses or uncertainties are. And then any work that we do from that point that's done in Canada by a Canadian employer, or what we call a taxable supplier, is in. And it's literally that easy. Okay? It's easy in principle, but to put a system in place that does that, I'm finding, is really the art more than the science. Okay, so again, terms like hypothesis and that, if you want to argue this in court, you're going to go to different definitions. What does Wikipedia say? Things like that. And again, really what they talk about, they often have a form of a mathematical model. They're based on previous observations. They require that someone can test it or repeat it. These are all terms that the CRA looks at. Repeatability, which is again why you want to record measurements, why you want to document them, why things that, if you do prototypes with no measurements and you shred the prototypes and don't keep any evidence, you're probably going to have a hard time claiming. Sounds funny, but I mean, a lot of guys, they got to do it. They got to get a quick solution for the client. They don't feel the time to do the documentation properly. And what I say is at least take pictures of the prototypes, number them. That's good enough, if you can explain it. But if you throw them in the scrap heap and you've got no evidence, again, this is putting a lot of power in the CRA's hands to rationally deny why you shouldn't be in. Okay? So really, what we recommend is something called a test matrix, which is you rank your variables, and you see if I change variable X, how does that affect Y, Z, and the others. Okay. All right. So the last part of the process, and going back to the tax court cases, what do the courts say about work being done systematically? What do I need to show that it was systematically? And they say scientific research must mean the enterprise of explaining and predicting and gaining knowledge of the subject matter of the hypothesis. Okay, so again, tie it back to the variables of the hypothesis. Would include repeatable experiments where results are carefully noted. So again, if you miss any of these steps, and it sounds funny, but when people do R&D random on the fly because they need to get a product out, and they've got 30 years experience, so they're like human computers calculating the variables in their head to get to the answer. If that's not recorded, and it happens a lot, that kind of stuff could be seen as trial and error, and it just takes a little bit of tweaking to get it back on there. Right? So when they talk about distinguishing routine activity from SR&ED, it's not only scientific method, not only just documenting what you do, but the entire scientific method, going from uncertainty through testing of a hypothesis. So again, the courts themselves have started to refer to that international definition scientific method, which I really like because I don't really have to explain anything. Once I say scientific method, then we're just talking about the specifics of how do we document the scientific method. Okay, conclusions, we've talked about it. The rejection of a hypothesis can be a technological advancement. We've proved that hypothesis wrong. So it's the understanding that really represents the advancement. Much scientific research involves just that. The initial objective is not a change, but the very failure of our process can stress its uncertainty, or the fact that there's uncertainty. And that's true, that the CRA is going to appreciate the fact that I wouldn't do an experiment if I knew it was going to fail necessarily. If I did an experiment that I knew was going to fail, I probably thought it was going to work, or maybe I suspected it would fail, but I still wanted to understand why. Either way, that's a strong indicator. So I would always try to focus on the failures. What did I learn from my failures? Well, I'll not do that again, as much as the successes. And the problem with most new claimants is they tend to focus on the business successes rather than the technological conclusions. Okay, so we just want to reshift the focus a little bit. Usually the information's there, but the focus is on the wrong part.